we have the triangle inequality theorem, and understanding what it says is absolutely relevant in how we're going to use it here. So we have this question. It says state if the three numbers can be the measures of the sides of a triangle. So we want to see if a triangle can exist with these measures, with these side length measures. Okay, uh, so let's see. Well, it needs to be that the triangle inequality theorem holds, right? That the sum of any two sides, okay, must be greater than that third side. So you need to sit here and you need to go, okay, is 7 plus 19, is that greater than 9? Yes. Is 19 plus 9 greater than 7? Yes. But the two things you should really do is just add the two smallest sides. And those two sides, the sum, right? The sum of any two sides must be greater than the third side. So is it true? Is 9 plus 7, how does that relate to 19? Well, 9 plus 7 is 16, and that's less than 19. And that cannot happen, okay? The sum of two sides, is always greater than the third side. This has to be true. And is this true in this case? No, right? It's not true. So this one is a no. You cannot have a triangle existing with these side lengths. And if you look at the previous video, you should be able to see why that's true, right? If I have not if a side length of 9, let's say that's 9, whatever. Let's say that this is 7, right? If this length is 7 and then this length is 9, when I expand this angle out, the most that I could get for the resulting side, this length, is going to be 16, not even 16. The most I could get is less than 16. Because when it's perfectly out like a line, a triangle can't exist when it is 16. Okay, and that's sort of like going into the proof of why this can't happen. Okay, proving this here. But okay, now let's see the next one. So let's see, is it true that the sum of any two sides is greater than the third side? So is it true? 3 plus 9, is that greater than 10? Yes. 10 plus 3, is that greater than 9? Yes. Okay, and so forth. You really don't need to check. You only need to check the two smallest sides. The sum of the two smaller sides needs to be greater than the third side. Then everything else just falls out, right? What's the last combination that I didn't try? 10 and 3. 9 and 10, of course, is greater than 3. And that's the sum of any two sides, right, is greater than the third side, okay? And then that's it. So this one's yes, this one worked. The sum of any two sides is greater than the third side. Now, what you could be asked is a question like this, okay, where it says two sides of a triangle have the following measures. Find the range of possible measures for the third side. So let's call that third side x. Let's use, I don't know. Let's call that third side x. Okay? And let's call it x over here for when we get there. What do I know? I gotta have it. I gotta have it that 9 or 8 plus 9 is greater than x. Okay? The sum of the two sides must be greater than the third side. But simultaneously, the sum of x and 8 has to be greater than 9, right? And what this gives you is that x has to be less than 17. That puts a bound on how high x can be, right? But if you minus 8 on both sides, right, I have that x must be greater than 1. And that means that I have this range of values for x. Okay, one way you could see that is you could just take the bigger number, subtract the smaller, and then you know x has to be greater than that value. Right? If x is 1, 1 plus 8, is that greater than 9? No. So x has to be greater than 1. X has to be, some value greater than 1. 1.0001 plus 8 is greater than 9. So the sum of any two sides is greater than the third side. But this is how you would see that using the theorem, right? If this is x, it must be that x plus 8 is greater than 9. So then now you minus 8 on both sides and you get this inequality. this inequality with the original inequality, right? 17 is greater than x. That could be said x is less than 17, right? These two in conjunction, right? These two in conjunction just give you this whole thing, which says that x is between 1 and 17. That's a nice way of writing it. If you have trouble with the inequalities, come to me with it. Come to me and be like, I don't understand the inequalities. I'll help you out with the inequalities, okay? But understand the geometry, or try and understand the geometry as best you can. I'll explain the inequalities if these inequalities don't make sense. But now again, right, what do I have here? I must have that the third side is less than the sum of the other two sides. So I must have that x is less than 17. The sum of any two sides is greater than the third side. This is the sum of two sides, this right-hand side. The third side is x. So x, in this case, again, must be less than 17. But now, right, I also have that x plus 6 must be greater than 11. And I minus 6 on both sides. And x has to be greater than 5. And I put the 5 right there. This is the same thing, right, as x is less than 5. I'm sorry, wait, did I do this right? No. This is the same thing as 5 is less than x. And that's what you kind of have here. And then you have this part right here, right? X is less than 17. And you just join these together to get this range of possible measures for your third side. You're continually just using this theorem. Okay? If you go wrong and you have that theorem in your mind, you could be like, well, the sum of any two sides must be greater than the third side. So x plus 6 must be greater than 11. And now you get one, you're going to get some inequality. And then it's just a matter of figuring out how these two things come together to get this inequality. Again, if you don't know the inequalities, come to me on the inequalities. This is your answer for one, and then this is your answer for the other one.